Hello, friends. Welcome back to the podcast. Just real quick, are you frustrated with the price of housing? Well, I have good news. You're not alone. And depending on how you feel about mud, I have also some other kind of good news. ETH Zurich researchers want to build homes out of mud. I know it sounds crazy, but just trust me. It kind of looks cool. It's good for the environment. It's affordable. It's kind of a win-win if you're willing to be a little experimental. So with that said, let's get down and dirty in the mud and build a house from the ground up. All right, friends, welcome back to the Next Bite podcast. Today, we're talking about a hot topic. We're talking about housing, specifically how housing can actually be made cheaper with additive manufacturing. But before we get to that, we're going to talk about today's sponsor, and that's Mouser Electronics. Folks, if you've been a fan of this podcast, then you know we love working with Mouser. Now, why is that? Well, it's actually pretty simple, right? Mouser's really aligned with what we're trying to do here. And what we're trying to do here is explain cool, interesting topics in a way that's accessible to everyone. And so Mouser, being one of the world's biggest electronic distributors, they have connections to academia, they got connections to industry partners, and sometimes they write about their insights. And we're going to be linking one of their resources to the show notes on today's episode. It's all about additive manufacturing, a quick history of it, the current state of it, and what the future looks like. One of the most important things in that resource, at least to me, is the role of on-demand manufacturing. So, in the past, if you wanted something, you had this very long lead time to make the tools, and then you get to manufacture it. And if you wanted to change something, then you're kind of out of luck because you have to wait for retooling. Well, now with additive manufacturing, and another huge benefit of it, depending on your application, is sustainability, because you're not wasting materials anymore. Now, that's not to say that additive manufacturing doesn't have its own drawbacks, but this resource gives you a lot of ammunition so that you can come up to speed and be, more well-versed in terms of what's going on. And I think it's a perfect primer because it touches on a lot of the points, both on the pro side and the con side, when it comes to additive manufacturing as it relates to today's article. So, folks, if you're interested,
that's what I was going to say, man.
Check it out.
They talk about shorter lead times. They talk about on-demand production. They talk about sustainability. They talk about having a resilient supply chain. These are things that we think about usually in like a product manufacturing perspective. But today we're talking about construction, which is manufacturing of buildings. And it's a great reminder to me that a lot of the same principles that apply in manufacturing a product also go into manufacturing buildings, very similar here. So I think it's awesome. You mentioned it, but a lot of the parallels from this 3D printing revolution article draw straight into where we see the impacts of 3D printing in today's episode with construction.
Absolutely. So with that said, let's actually jump into today's article. And this is from our friends over at ETH Zurich. We've already kind of spoiled it, but we're going to be talking about additive manufacturing and how it relates to construction. Now, again, if you've been rocking with the podcast for some time, then you'll know that one of the first episodes that we did was actually around this topic of additive manufacturing for creating homes. And specifically, we talked about the first home in the United States that was up for sale, created using additively manufactured concrete and its pros and cons. And if I'm not mistaken, it stirred up quite a bit of controversy on our Instagram page because you had people that were like, I love this. I want this to happen so it can bring the cost of housing down and it's so much more robust. And then you had others that were like, this is so fragile. How are you even going to be able to work with it? What about plumbing? This is never going to happen. So it was a very divisive topic for our audience, right?
Well, and I actually, it was one of the first times where I felt like we had a conversation with our audience, right? In some ways, it's you and I talking into the abyss and hoping that people in the world resonate with this. But that's how I felt in the early episodes. Now I feel like it's truly a conversation. But this topic, 3D printing and construction, is one of the first things that opened my eyes up to this paradigm. Like, oh, we're having a conversation. And I agree, right? There's a lot of solid feedback, folks saying, this is awesome, I want to use it. But there's also a lot of good questions. Like, hey, does this require just the same amount of material as normal concrete manufacturing? Why wouldn't I just do that? Because molds are faster than extruding with 3D printing. How do I handle plumbing? How do I handle if I want to hang a poster on the wall. Like if the two posters ever got on the wall behind me, is that harder on a 3D printed concrete house than it is in a house with drywall? Maybe. So I thought that was an interesting throwback there, just to think about that and reminisce on how it's impacted the podcast. But I think a lot of those questions still apply, especially the environmental ones related to construction, with material waste, with pollution, with greenhouse gas emissions, and like we were saying, having a non-resilient supply chain as well, right? Nellie and I had our house built. It was a new construction house over the course of last year, and it was supposed to be done in sometime like May or June, and then it ended up finishing in sometime like July or August because of delays with certain materials that they had to build. And this isn't even the worst of the stories that people have with new construction homes and the construction industry. So a lot of those pain points that we talked about many episodes ago still exist today. And I like the idea of like using additive manufacturing for building houses. But today, what we're talking about, we've alluded to it a little bit, but it's an even more interesting twist than 3D printing concrete, which we talked about a long time ago, and we've seen a bunch of different examples of in technology realm since then over the last 2 years or so. This one, in my mind, is something that I've seen that's truly feels like something different.
I totally agree with you, man. And before we get into the tech itself, I quickly want to talk about the motivation for these folks over at ETH Zurich. Now, similar to, I'm forgetting the name of the company that we talked about almost 3 years ago, but similar to all these other companies that have taken on the initiative of using additive manufacturing for construction, these folks were inspired by what seems like a state of lack of innovation and monotony when it comes to construction, right? The construction space has struggled to digitize, whereas, you look at other industries across the board over the past 10 years or 20 years, they've been doing their best to keep up with the exponential progress in technology. And these folks identified that as an opportunity. Then you look at the environmental aspects of construction, right? In a different episode where we were talking about graphene and how it's able to reinforce concrete, we discussed how I think something like 5% or 3% of the world's CO2 pollution is just because of concrete production. So that they didn't even account for the transportation factor, right? And these folks that were highlighting this in the paper, where they're like, not only is the creation of a lot of these products harmful to the environment, but then the transportation of it, and then you have a lot of labor that's required on site, et cetera, et cetera. Basically, this industry is ripe for someone to come in and disrupt it. And then they're willing to give credit to the folks that have been taking on 3D printing concrete, right? They're like, hey, this is definitely an alternative. We've seen it pop up, but we still don't see that as a viable alternative. And here's why. They highlighted that the current state of 3D printed concrete platforms require you to input materials to strengthen the mix that actually make it even worse for the environment when you compare it to traditional reinforced concrete that you're able to just pour into, like you were saying, into a form.
I didn't know
In addition to that, yeah, I didn't either. I think that's probably something that big 3D printed concrete industry wants to hide from the average Joe. But then they were also talking about something that I didn't take into consideration at the time. Because of the formulation of the 3D printed concrete, so that it can actually go through the nozzle and be layered on and on and on. It requires a higher, I think, water content. And over time, there's concern about how fragile and brittle it might be in comparison to, again, your standard concrete pour. And when you're thinking about a home that you would want to go on as long as possible, these structural failures, potential structural failures, don't really sound too appealing. So these are some of the elements that they were fixating on. And as an inspiration, they looked at how people have been building their homes for, centuries. And the topic that came up was earth, so basically the soil that you're standing on in the area that you want to build your home. And they said, look, a lot of people have used earth over time to mold it and build their homes across the world. So this is a possible way of doing things, but it has its own set of drawbacks. Along with those, probably the most important are the amount of work required. It's very expensive, very slow. It's very labor intensive. The end structures tend to be fairly reliable. And on the pro side, you're using a material that's very abundant on site. So That allows it to be cheap. That allows it to be accessible. You don't have to worry about supply chain like you and Nelly were. The end material is very fire resistant. It has great acoustic isolation, so you don't have to worry about your noisy neighbors. It has great moisture regulation. So, we care about HVAC and how moist it is over here in Virginia when humidity can kill you in the hottest summer days.
Yeah.
So these are all a lot of pros, but again, those the three main cons that I pointed out have prevented it from being adopted in a really meaningful manner in the modern age of construction. So with all that in mind, the question that the team at ETH Zurich was asking was, can we bring together this technology of additive manufacturing and the benefits of using earth as the precursor material to kind of get the best of both worlds? And that's where our story starts.
Well, and just to even step back here and be like, using specific materials for construction. I think back from a historical perspective, ancient civilization, the first civilizations, when they built houses, they were building houses using the dirt underneath them, right?
Yep.
Maybe reinforcing it with straw, but mud houses or saw houses, like this is not a new concept by any means.
Nope.
But I love the idea of kind of going back to like almost the roots of construction as it exists today, mixing it with what we see to be like at the cutting edge of technology and creating a solution here that leverages, like you're saying, the best of the best in new technology and the best of the best in terms of using the most abundant material anywhere you're building. And that's sourcing raw earth material from the ground around you, adding some additives to it to make it a little bit strong enough to be able to be, constructed into a permanent building, and using that as your main source of material. So I think this, to me, draws very similar parallels to, the way thousands and thousands of years ago people first started to build houses. We're taking a very similar materials approach here to solve this problem.
You're not wrong, and there's definitely a bit of irony in bringing in a new age of construction by referring to the approaches of hundreds of years ago. But that's what's exciting about tech, right? Like you're constantly rediscovering these technologies, and a small spin on it can completely drastically change what the end outcome actually is.
Yeah,
so
exactly.
Let's get into their tech now. We've teased it enough. So again, the idea is additive manufacturing, but the material that you're shooting out is no longer concrete. It is now going to be dirt, just plainly put it. And they give credit to some folks that have attempted to take on this challenge before, and they recognize that although there were some accomplishments, there were some critical drawbacks. A big one of those being that they required reinforcement material that also added to the pollution that they were trying to, get rid of by moving away from concrete. So that kind of defeated the purpose. And then they talked about the difficulty to, dirt compounded on top of each other is quite heavy. To build a structure that's stable at a tall enough height for it to be feasible for some sort of a building structure. And they talked about how, shrinkage is an issue. You have a lot of water mixed with this dirt to make it actually go through a nozzle. When it dries, it can contract essentially. And they talked about yield strength, which is a huge throwback for you and I, going back to material science and solid mechanics and the importance of it. So they had these challenges, and with that in mind, they knew they had an uphill battle ahead to come up with a novel approach that beat what anyone else has been trying to do. And what they came up with is called impact printing. And there could not be a more descriptive name in terms of what's happening.
Perfect name.
Like maybe up there with additive manufacturing, right?
Yeah.
It's got a nice acronym, IP, very easy. And the idea is you use impact, so using the dirt water as projectile essentially, to print, because the benefit you get from throwing something at a very high speed is making sure that it adheres very, very well to the layers beneath it and creates a sturdy construction from the ground up.
Well, and that kind of solves a lot of even just that portion of the approach kind of solves a lot of the problems you were just talking about, right? In
Absolutely.
terms of the mechanical strength, right? In terms of having to be concerned about layers adhering to one another. That's not a new problem in additive manufacturing. That's probably the main problem in additive manufacturing, is the fact that it's a unique manufacturing method that creates, in many cases, layer lines that are very, very easy, cause potential failure points for your material. So in this case, impact printing does a perfect job of completely getting rid of layer lines, unlike when you see some 3D printed concrete, right? You see layer lines where each layer was deposited on top of the next. One of the things that's awesome about impact printing, and I'm kind of jumping ahead of ourselves here, but they take a cross section of one of these walls that they've printed with impact printing, and just because they're literally mud slinging, they're slinging mud fast enough that all the layers kind of get compressed and amalgamate into one structure. There's no visible layer lines. It looks like one solid mud wall, which is exactly what you want for a mechanical perspective, right? For a lot of the things you were talking about, not being able to build rigid enough, strong enough walls that are tall, not being able to handle things like shrinking where there's already layer lines that cause a origination point for a crack, and then obviously not having enough mechanical strength to withstand all the forces of building a house and building entire structure on it. Just the fact that they use impact printing as opposed to just extruding something out of a nozzle and letting it sit on top of the previous layer, the fact that they're shooting blobs of this mud down into a pile, in my mind, that solved a lot of the problems right there, just using the impact printing without even talking about how they've innovated in terms of the material.
For sure. And another thing that was really interesting to me is, obviously they have the impact component, right? You're shooting mud at a high rate very frequently, and that's helping you get this layer adhesion, which we know is critical in the world of additive manufacturing. But then, they had hinted at this early on in their paper and in the article. They're like, hey, stability is really, really important here because of the weight and also, the impact that of our printing process. The structure that we're printing on needs to be able to support this. So when it comes to stability, they're actually doing some wonderful magic behind the scenes. If you're a fan of 3D printing, I'm sure you've used a slicer where you put in the object that you want to print. It does some magic. It goes, layer by layer. It basically writes up the code for your printer head to move in the right direction. Well, their proprietary system that they set up not only does that, but also it looks for, in terms of the toolpath, it looks for weak links when there's overlap as you're, let's say, tapering. Like if you want to make a column that's sturdy at the base, but then it gets thinner as it goes up. It looks for areas where there's too much overlap or too little overlap, which could result in heights being slightly off. And over time, you could have a portion of your design be too heavy and lopsided and therefore cause instability. And it iterates on the original toolpath over and over and over and over again until the final toolpath has the perfect amount of overlap with every single layer and every single drop. And I just think that's fascinating. Like you can definitely take that and, I don't know, take it for granted as an end user, but it's really important to call out because, as we've seen before, a great slicer can make or break a printer company. In the world of hobbyists, it was, I think, Prusa that really overhauled what it meant to have a great slicer.
Yeah, I'm with you, right? And that is, right, we talked about the mechanism, right? It shoots earth at a high speed into a pile to create the wall. That's one important part of the secret sauce to me. You mentioned the other one, right? The kind of robotic system and then the software that comes alongside that not only controls this nozzle and this mechanism of manufacturing, but also strategically depositing it in the right area, ensuring overlap, avoiding dislodging, right? They experienced that in the beginning when they're developing this. It's like, oh, I'd shoot a little bit of mud at the pile of mud that I already had, and it's causing the pile that I already had there to explode and dislodge, right? That's not an outcome you want either, right? So they have created a custom software strategy to look, that's been trained based off of their experience using this very unique manufacturing method to create a strategic tool path to ensure that you're able to create the structure that you want without any issues. The last part here that's really interesting to me, we talked about mechanism, we talked about the software, and now I want to talk about the material, right? We already alluded to it a little bit, right? They want to use raw earth from the area where the construction site is being, where the construction site is, right? And they want to use as much of it as they can. You already alluded to it as well. It does no good if you use 60% dirt and then have to use 40% really, really expensive, really, really high carbon footprint additive. That erases the gains that you get in terms of reducing the carbon footprint and reducing the reliance on your supply chain if you need a lot of this other additive material. One of the things that I thought was awesome is they were able to pre-process the raw earth, the clay and the silt, to try and get fine particles. So they basically ground up the clay and the silt from the raw earth, and then they mixed this with a minimal amount of additive. I think they called it hydraulic lime, less than 3% of this additive. So 97% raw earth, 2.5% hydraulic lime. This mix is specifically designed, it supports the impact forces during construction, maintains enough plasticity that it's able to reshape when the next layer hits on top of it and create this, like we said, a single structure with a cross section that doesn't show any layer lines. And one of the things that I thought was awesome there is they're not just like spending a lot of time and money processing this clay and silt into this fine particles that they need. They actually were able to use a waste product, I think from a construction company. So they were able to use a waste product of dirt from this construction company that already had this earth mix with a fine particle count, and was locally sourced, and they were able to use that for the 97% additive in the recipe where, that's the most important ingredient.
And one thing that really surprised me, that the 3% number, I had no context of if that's impressive or not, right? The hydraulic lime, that's what I'm referring to. 3% by weight. When you compare that to the traditional methods that use earth for construction, they would need anywhere between 15 to 20% by weight so that the construction, the end product, could actually be stable. This is incredible. Like, again, just every one of these accomplishments by themselves is impressive. Put them together, this is a pretty impressive leap forward in terms of what the construction industry will be capable of doing, hopefully in the not so distant future, right?
Yeah. I'm with you. Before we kind of zoom out and wrap this thing up, I do kind of want to I can't say off the record because we are literally recording right now, but I kind of want to have like a sidebar discussion, let's say.
Let's do it.
Just how this looks and what the end product looks like.
Yeah.
I don't know of a non-crude way to say this, but if you watch the video, do you know where I'm going with this?
I know where you're going with it.
If you watch the video of the pod of earth being extruded out of this hole, and then they kind of like pinch it off, and then it drops at a high speed and lands on a pile, it almost looks like someone dropping a deuce. I don't know of a better way to say it. It's not a pro or a con, but I do think it's really interesting to, like, I don't know, to come up with this technology that it feels so not construction-esque, right? It feels more like a bodily process, but it works so well. And one of the other things, I guess that's a con. I don't know. Maybe it's a pro, depending on how you think of it. But a pro for me, I love the unfinished product. So I have like a bunch of tools they're working on, like grinding the walls to make them smooth so that they're more amenable to construction. I love the look of the unfinished wall, which shows every single, like the outer layer of all the pellets that were dropped, to create this kind of like bumpy wall material. And I wonder if there is some artistic element of this as well. That's like, where the construction method lends to the architectural benefit, right? The art, kind of the way we talked about 3D printing concrete. Like if you have to create weird geometries to make sure the wall stands up straight, maybe you can play into that and be like, oh, I want there to be cool geometries. I'm wondering if there's someone, some benefit here, or some architect that wants to use this technology to create a really, really cool looking house, because it truly does look like a piece of art, the final product, before they grind off the walls to make it smooth.
I agree with you, and I'm happy you brought it up. Just very quickly, my sentiment regarding the aesthetics of the outcome that they've displayed on their article It's kind of like, I don't know if you saw the episode of Kelp Juice on SpongeBob, where
No.
it becomes, so there's kelp juice and it becomes super popular. And everyone who drinks it, it's like, oh, ew, it's disgusting. But they keep drinking it because they're like, the aftertaste is really good. And you kind of start to come around to it. When I first looked at it, I have cats. It reminded me of their clump litter that I clean every night, right? As I read the article and I saw more and more pictures of it, it kind of grew on me. And it grew on me in the sense of, it reminds me of those castles in House of the Dragon. And it kind of looks cool and artistic. And it looks like scale, but like on a wall. I could be into it. You know, it could definitely have, with the right artistic vision, this could be very impressive.
Well, I'm going to mention something. I don't know if this is like a core memory just for me and my siblings growing up, or if this is a shared memory, a shared experience that all of us had. But did you ever go to the beach and like grab wet sand and then hold it in your hand and let it drip, and it like kind of creates a castle?
Yeah. I know.
So this is a shared experience. This is pretty much exactly what this does for folks who haven't yet gone to the show notes and clicked on the link and watched the video, which is absolutely what you should do.
Yeah.
But if you haven't done that yet, might give you a good mental picture. Is if you grabbed a bunch of wet sand and you're letting it drip out of your hand, and wherever it drips, you're kind of creating a wall, and then you build a castle like that. That's exactly what they're doing, except they're doing it in a way that won't get knocked over by the wind or washed away by the next wave that comes up. They're doing it in a way that actually makes something that, at least from their initial indications, looks like they can accurately integrate architectural fixtures during the build, such as windows and doors. It's high speed. It's doesn't require formwork, so you don't have to create all these molds. Uses local, low carbon materials, and apparently is strong enough and versatile enough that you're able to use it for real construction. So think about making sand castles as a kid, but in a way that actually works.
I'm happy you brought up the beach, because it just reminded me of one of the bigger cons that we talked about, which was cracking with, as the earth structures cure. One of the big ways that these folks got around that real quick, in strategic areas, they placed these wooden reinforcers, which as the whole piece started to cure, it prevented the cracking from happening to begin with. And strategically, they designed the pieces so that there are areas where there's gaps. So if there's ever a crack to be formed, it's very accessible and easy to repair by someone else. So yeah, two cool things that I wanted to highlight before we start wrapping this up.
Yeah, that's awesome.
All right. I guess on that note, we are good to wrap it up, right? Nothing else to talk about?
One thing I wanted to mention, the 3D printed home that we talked about in episode 9, by the way. That's a long time ago.
My God.
I just looked it up on Zillow. Looks like the estimated retail price is $567,000.
Doubled in price.
Yeah. It almost doubled in price over the last couple of years, which is crazy. Glad to see that the first 3D printed home for sale in the US has actually seemed to appreciate quite well.
Yeah, glad we were part of that wave, the early wave.
Yeah, exactly. I don't know. Other than that, I think we're good to wrap up.
All right. Folks, are you frustrated with the prices of housing? Well, you're not alone. Everyone is feeling it, not just in America, but across the world. So these folks over at ETH Zurich have a very novel solution: mud. And I know, before you click away, just trust me, they are being inspired by how we were making our homes centuries ago. And they want to bring it together with additive manufacturing. Together, they've proved that you can create structures that are not only strong, but also really good for the environment. And honestly, they kind of look cool. I'm a fan. Daniel here is a fan. And if you're looking into your next home purchase, but you don't want to pay those crazy prices, you might want to check this out, because it could be the future of construction.
I dig it.
Yeah?
Yeah.
Thanks. I do what I can. With that said, folks, thank you so much for listening. And as always, we'll catch you in the next one.
Peace.